So in the last class we have discussed about the components. In this class I will extend this discussion towards ahead. So let's uh, consider about an example. So in a system what is there? In a system NaCl is there, KCl is there, and Na plus K plus Cl minus are there, and also water in liquid state and water in vapor states are present. So in this system what will be the number of phases and the number of components we will describe. So suppose this is one beaker. So inside the beaker what is the present? Water vapor is present, water vapor, and water is present in the liquid form. So and inside the waters what is present? Sodium chloride and potassium chloride. So here the number of phases will be what? 1 2, because whatever the salt we have added here, it will completely dissolve in water. So the number of phase will be 2. Here the number of phase will be 2. Now our point of discussion is how to define the number of components in a given system. So let's write different equation. So NaCl when dissolve in water, it will furnish Na plus ion and Cl minus ion. Similarly, when potassium chloride is dissolved in water, it will form potassium plus ion and Cl minus ion. Similarly, in this system, water in liquid state is in equilibrium with the water in vapor state. So, what are the number of relationships? 1, 2, 3. But we have to remember, in the case of chemical equations, electrical neutrality is also a pivotal point. Whenever we are calculating the number of relationship, also we have to count the electrical neutrality as one of the relationship. So in total how many relationships are there? Here 1, 2, 3 and 4. So what will be our number of components? C equal to n minus E. Here n is equal to number of constituents, and E is the number of relationship between the constituents. So in place of n, what we will write? In place of n, we will write 1, 2, 3, 4, 5, 6, 7. So there are 7 number of constituents are present. And what will be the E? E is the number of relationships. So here 1, 2, 3, 4. Always we have to count the electrical neutrality as one of the relationship. So we have to write in place of E, that is 4. So 7 minus 4 equal to 3. So the number of components for this reaction will be, the number of components for this system will be 3. Now little bit we will discuss about the degree of freedom. What is the definition of degree of freedom? Minimum, what will say? Minimum number of variables required. Minimum number of variable required to define the system. Is called degree of freedom. It is represented by F. If F equal to 1, that is degree of freedom is 1. 1. So the system is, what you can say, the system is univariant. The system is univariant or monovariant. Univariant or monovariant. Similarly, if f equal to 1, the system is bivariant or trivariant. Similarly, if f equal to 3, sorry, here if f equal to 2, it is bivariant. Similarly, if f equal to 3, it is trivariant. And the most important point is, if f equal to 0, it is called non-variant. That means it is not dependent upon any variables. That means it is not dependent upon any variable. So in this class we have discussed something about the components and little bit we have discussed about the degree of freedom. In the next class we will enunciate, we will thoroughly discuss about the degree of freedom with some examples. So that's all for this class.